has to assign, the user can do. You can configure these authorities in Spring application. This term, in the context of the application, is super important. There may not be a one-to-one mapping between a user or a human being and a principal. Okay, take Google for example. A single person can create multiple Google accounts. So Google has multiple email IDs or accounts sitting in the system that actually correspond to one user. If the user logs into Google, let's say they're using the credentials of account A, then the principal corresponds to account A. There is a currently logged in user which corresponds to account A. Then the user can switch that current login to account B and the principal corresponds to account B. So the best way to think of the principal is as the currently logged in user or currently logged in account. Okay, on to the fourth term and the fourth concept. We've looked at how authentication happens, knowledge-based or position-based or whatever else. Now how does authorization happen? How does the application decide whether or not to allow a particular access? Well, that has to be coded in beforehand, obviously. The application owner or maintainer should have specified beforehand, okay, if the user is this, allow them to use only these actions. The user is this, allow them only these other actions. So it's like a bunch of permissions that are allowed for a given user. In Spring Security, this concept of permission is called authority or granted authority. Authorization, authority. Get it? The user is trying to do something in an application and the application will allow or authorize them to do it only if the user has been granted authority to do so. Taking that retail store example again, the store clerk has the following authority: do checkout, make store announcements. The department manager has authorities: do checkout, make store announcements, view department financials, view department inventory. The store manager probably has all these authorities plus things like view store financials. These are authorities. These are fine-grained permissions of what the user can do. You can configure these authorities in Spring Security for users, and Spring Security takes care of the rest. Any operation that hasn't been specified explicitly as permitted for a given user, well, the user just cannot do the operation. They can have access to only the operations allowed beforehand, or otherwise the default response is no. Now here's the thing with granted authorities. Most of the times, for most applications, they're usually too fine-grained. Let's say the retail store hires 5 store clerks. Now each of these store clerks, someone has to assign all the right authorities every time. Every time a store manager is hired, someone has to make sure all the right authorities have been assigned to them. So this can be tedious. This is where you create the concept of roles. Role is pretty much like a group of authorities that are usually assigned together. So here you create something like a role store clerk and assign all the authorities that the store clerk should have. So when a store clerk is hired, you assign them to this role and automatically they get all the clerks. Now each of these store clerks, someone has to assign all the right authorities every time. Every time a store manager is hired, someone has to make sure all the right authorities have been assigned to them. So this can be tedious. This is where you create the concept of roles. Role is pretty much like a group of authorities that are usually assigned together. So here you create something like a role store clerk and assign all the authorities that the store clerk should have. So when a store clerk is hired, you assign them to this role and automatically they get all the authorities for that role. Role department manager is a role that groups together all the permissions that a department manager should have. See, this makes things super simple as well as makes things consistent. Roles are more coarse-grained permissions, unlike the fine-grained permissions that authorities have. I should mention that with Spring Security, both these concepts of authority and role are often used interchangeably. In most cases, the difference is literally just the naming convention used. You'll see similar APIs work both with authorities and roles. But remember that the concept differs mainly in how fine-grained the permission is. Fine-grained permissions are authorities. More coarse-grained grouping of permissions are roles. So these are the 5 Spring Security concepts: authentication, authorization, principal, granted authority, and roles. These are what you can control with Spring Security. You'll be interacting with the framework to configure all these different things: the authentication, authorization, identifying the principal, specifying authorities and roles, and so on. But the thing is, you don't have to do any of this configuration to add Spring Security. Spring Security can be very simply just added to any Spring Boot application, and it has some secure out-of-the-box behavior without you having to configure anything really. Check this video out to learn how to add.
If you want to become a pro Python developer without having any prior knowledge on the subject,
and you have a bunch of subnets here, which are basically what do the work when a user makes a request, right? So a user makes a request to a URL, and then there is a particular subnet that does the functionality and provides a response for that particular request. And the way it works is, depending on the URL, the right subnet is picked, right? The subnet container looks at the URL and says, okay, this URL needs to be handled by this subnet, this URL needs to be handled by this subnet, and then it picks the right subnet that needs to do the job, and then it executes a method on that subnet. This is how sublets work. But think of filters as kind of like cross-cutting concerns. Filters kind of stand right in the middle and they intersect every request. And this gives you an opportunity to do something with every request. You can kind of think of it as cross-cutting pieces of functionality that you can use to log every request, for example, or check every request to see a particular header is there or not, stuff like that. So while subnets are mapped to URLs, filters can be applied to all URLs. You can put a filter in there and say, okay, this filter needs to intercept all URLs, and then you have that filter allow or deny based on the request itself. Well, guess what? Spring Security is doing exactly that. Spring Security is just putting in a filter there and saying, okay, now I'm going to sit here and examine all requests to allow or deny requests as per what I should be doing. There are a bunch of things that Spring Security does by default. First of all, it adds mandatory authentication for all URLs. Let's say you have a Spring Boot application with a bunch of URLs. You throw Spring Security in there. By default, without any configuration, it makes sure that authentication is required for all those URLs. When I say all, there are a few things that it does skip authentication for. For example, the error page. Spring Boot applications come with a /error by default. Well, Spring Security does not secure that because you don't typically need authentication to show error messages. But in general, it adds authentication mandatory for all your APIs. It's the first thing that it does. Second, it adds a login form. We've seen that. There is a /login route which brings up the login form. It adds that controller to your application. Next, it handles any login errors. It has this authentication logic where it examines your user ID and password, and then it validates and makes sure that that's correct. If it's not correct, it shows a login message, which we've just seen. But now you might be thinking, hey, hang on. What is a correct user ID and password? Because we haven't done anything. It just added Spring Security. Where is it getting its user ID and password from? Well, Spring Security is saying, okay, now somebody has added me to the class path. I make things mandatory authentication by default, but turns out this developer has not given me a user ID and password to authenticate against. Now here's what I'm going to do. I'm going to create my own user ID and my own password, which is exactly what Spring Security does. So this is the fourth thing that Spring Security does when you add it to the class path. So it's created a user ID and password, and that's the reason why it's showing up a login form for us and it's not allowing us to enter. But now how do I figure out what that user ID and password is? If you look at the console log over here, you see this? It says using generated security password. So this is the password that it has generated, and by convention, Spring Security creates a user called user. So this is the user ID and password that Spring Security creates by default for our Spring Boot application just by adding that dependency. I'm going to copy this password, go back to the form, enter the username user, this password, click sign in. There you go, we're in. So this is the default behavior of Spring Security, and just by adding Spring Security to the class path, we have achieved this functionality. You can of course customize this automatically created user though. So what you can do is go to your application properties, and you can add a couple of properties in here. So the first property is Spring Security user.name, and then foo, and then again you can do Spring Security user password. Set that as foo as well. Right? So now you're basically telling Spring Security, hey, create the user with this name and this password. That one default user that you're going to create with this username and with this password. So when you start this application now, Spring Security thinks, oh good, now I want to do the default behavior of having authentication, but I don't have to create my own user. Here is this one user that this developer has given for me. So It's going to create that user instead of the default user. Now, if you were to start the application, look at the logs in the console, you will not see that created user with generated password message anymore, right? It doesn't do that because it doesn't need to. It's just going to use your user ID and password that you entered in your application or property. Now, if you were to open same URL and enter that username and password, foo and foo, we are in again. So this is how you add Spring Security to your Spring Boot application. Do this. The starting point for this video is going to be a simple Spring Boot application with the Spring Security dependency added, the starter Spring Security dependency. If you're not familiar with how to do this, check out this video in the card that's showing up right now. When you add the Spring Security starter dependency, Spring Security creates a default user and puts your application behind form-based authentication. You can, of course, configure what the default user is in the properties file, but that's not ideal for most situations. You would want to have the Spring Security authentication happen based on a bunch of users that you have, maybe in a database or some other external state. In this video, we are going to try out configuring this authentication by actually hard-coding a couple of users and saving it in memory. Now, the way to configure authentication in Spring Security is by affecting what's called the Authentication Manager. The Authentication Manager is, true to its name, something that manages authentication in a Spring Security application. So you can imagine Authentication Manager sitting in a Spring Security app and doing the authentication. It actually has a method called authenticate, and that either returns a successful authentication or it throws an exception when it comes to authentication. It says, I cannot authenticate. So Authentication Manager is what does the authentication. Now, how do you affect it? The way to affect it is not by creating your own Authentication Manager, but instead to configure what Authentication Manager does using a builder pattern. You don't work with Authentication Manager directly for the most part. What you do instead is work with a builder class called Authentication Manager Builder. You use Authentication Manager Builder to configure what the authentication should actually do. So there are two steps here. First step, somehow get hold of this Authentication Manager Builder. And second step, set the configuration on this Authentication Manager Builder. So you can imagine the interaction with Authentication Manager Builder being that configuration. So when you're dealing with Authentication Manager Builder, first thing it's going to ask you is, hey, what type of authentication do you want? And you say, well, I want in-memory authentication. And then the Authentication Manager says, okay, well then tell me what the username, password, and the role of your in-memory users are. And then you give it the user information. It could be one user or it could be multiple users. But once you've done this, once you've configured Authentication Manager Builder with these properties, you can imagine a new Authentication Manager being created somehow, which has the values that you want. So you're not directly dealing with the Authentication Manager, you're dealing with the Authentication Manager Builder. Now this begs the question, how do you get hold of this Authentication Manager Builder in the first place? The way to do this is by leveraging a hook that's already available in the Spring Security app. The thing is, in the Spring Security app, there is a class that's sitting there which has a method called configure, and it takes in as an argument the Authentication Manager Builder. And the Spring Security framework calls that configure method and passes in the Authentication Manager Builder. The reason that class is there is so that it gives developers an opportunity to extend the class, override that configure method, and do the configuration that you want. If you don't extend this class and override the method, the default configuration happens. However, if you were to just this security configuration, you can call this any name really. What's important is that this class extends a particular class called web security configure adapter, right? So this is the class that's sitting in the Spring Security app.
Thank you.